Okay, so today we're going to finish up, talk about that assignment that we gave yesterday. That'll wrap that up. That'll be kind of the last of the skill sets. And then we're going to actually get into the heart and soul of physics and how we begin to do calculations and study motion. So, kind of the quintessential example of what you have is that one item 18, where you have force equaling mv squared over r. So what this equation represents is like if I had this rubber stopper going around over my head. So what that represents is how much force it takes to keep a certain object, whether it's a rubber stopper, whether it's the earth going around the sun, moon going around the earth, doesn't make any difference. Some object traveling in a circular path. So you have the mass, whatever that is, you have how fast it's going, and then you're dividing by the radius. So here's the story. This is cool because it kind of encompasses the three main things that you will see most often in terms of manipulation. So one of the things that's got to become almost second nature to you is to be able to look at the equation and go, what is a factor and what is not a factor? And if it is a factor, what happens if I change it? Okay, it's one of the most, to really understand physics, chemistry, any kind of analysis, you have to look at what's a factor and what's not. So the simple one is the value of mass, because that's just directly proportional to the force. There's nothing wonky, there's no squares, there's no cubes, you're not doubling it, nothing, okay? So if I just double that mass, I'm just going to double the force. If I put on a rubber stopper that has twice the mass, and everything else is going to stay the same, hey, the force is just going to double, okay? That's the simple one. The velocity one's a little bit trickier, mainly because that's going to be squared. But if you look at that and you go, oh, well, that's 2v quantity squared. So whatever I put in there is going to get squared. So if I double the velocity, in other words, imagine you're driving your car, and you're going to, instead of making the turn at 10 miles an hour, you make that turn at 20 miles an hour. You're going to be going twice as fast. So if you double that velocity, what's going to happen to the amount of force it's going to take? It's going to go up by a factor of 4. If you triple it, it would go up by a factor of 9. Okay? So anything that's squared mathematically has a huge ramification about what happens. That's okay. Y'all are good with that. That generally isn't the problem. Where it gets a little bit counterintuitive is the radius, okay, because you're dividing, okay? But here's the story, though. Let's say, and again, this is just a simple idea. We could take 12 and divide it by 2. We could take 12 and divide it by 4. We could take 12 and divide it by 6. So Connor M., as I divide by a bigger and bigger number, what happens to the product of that division?
It gets smaller.
It gets smaller and smaller and smaller because you're dividing by a bigger and bigger number, okay? So when you look at doubling the radius, one option is you can go, okay, F equals mv squared over 2r, because that's what that means. Oh, I'm going to double the radius. Cool, right? Now, if you want to figure that out, you could sit here and go, oh, that's like saying that's 1/2 times mv squared over r. So that means that amount of force is going to be decreased by 1/2. So here's, and this makes sense if y'all have driven, right? If you're in your car and you take a really, really, really tight turn, that's a really, really small radius. And like, oh man, that's a lot of force, like, oh, right? Now, you take a big, wide turn, oh, that's not as much force because of the fact that the radius is bigger. So what you would say here is that force is directly proportional to mass, it's directly proportional to velocity squared, but it's inversely proportional to radius. So when we say it's inversely proportional to radius, that means as the radius gets bigger, the force gets smaller. Okay? Cool with that. All right, any questions on that assignment?
16. Can you go through it?
What's 15?
16.
16.
The shape of the graph.
Okay, here's the story. So your graph looks like, this is this position time graph. So it looks something like this. True? Okay. What does the slope of that graph represent? What are the units?
It's the velocity.
It's velocity. When something falls, what is it doing? Speeding up or slowing down?
Speed.
So to show that something's speeding up, the slope has to get steeper. It's a logic problem. Oh, slope represents velocity. If the velocity is getting bigger, the slope has to get steeper to show that increase in velocity. That's all you have to say. That's it. Do not make it complicated. Okay? Anything else? Going once, going twice? So get the labs on that, or excuse me, get your graphs stapled to the back and get that handed in. Very impressive. Stop that. We'll start it back.